Hello everyone, Jain to all. In this video lecture, I am going to discuss about an algorithm which is used to calculate all pair sorted path in a given graph, and the name of the algorithm is Warshall'S algorithm. The outline of this video lecture is Floyd Warshall algorithm introduction part, Floyd's Warshall algorithm, how to execute, Floyd Warshall algorithm, how to calculate the value of a given distance, and then we have to discuss a example. Floyd's Warshall algorithm. The Floyd Warshall algorithm named after its creation, Robert Floyd and Stephen Warshall, is a fundamental algorithm in computer science and graph theory. This algorithm is used to find the shortest path between all pair of the nodes which is given in the graph. It is used to find the shortest path between all pair of nodes in a weighted graph. The weight of edge is may be positive or negative. This algorithm is highly efficient and can handle graph with both positive and negative edge weight, making it versatile tool for solving a wide range of network and connectivity problem. This is used to solve how reach from one node to another node with a minimum cost or a shortest path. Floyd-Warshall algorithm is an all pair sorted path algorithm, unlike Dijkstra and Welford, which are single sorted path algorithm. In case of Dijkstra algorithm, we find how we have to find a shortest path from a single node to all pair node, but in case of Floyd-Warshall algorithm, we have to find shortest path between all pairs of nodes which is given in the graph. This algorithm works for both the directed and undirected weighted graph, but it does not work for the graph with negative cycle. That means where the sum of the edge in a cycle is negative. The calculation of weight in a cycle, if is the negative, then we can't find the value of the given graph. It followed dynamic programming approach to check every possible path going via every possible node in order to calculate shortest path distance between every pair of nodes. As we tell you, in case of Warshall's algorithm, we have to find the shortest path between all pair nodes. But by using Dijkstra and Wellman-Ford algorithm, we have to find the shortest path from a single node to all other nodes. So this is the advantage of Warshall algorithm, in which we have to find the shortest path between all pair of the nodes. Floyd-Warshall algorithm is basically used to find the distance between all pair of nodes. In this case, initialize the solution matrix same as the input graph matrix as a first step. In case of first step, first we have to draw a matrix in which we have to enter the value of edges which are weight of the edge. Then update the solution matrix by considering all vertices as an intermediate vertex. And then we have to, the idea is to pick all vertices one by one and update all shortest path which include the picked vertex as an intermediate vertex in the shortest path. This is the basically algorithm which is calculate the distance between every pair of nodes. So we have to find the distance between each node which is given in the graph. When I pick a vertex number k as an intermediate vertex, we already have considered vertex 0, 1, 2 up to k minus 1 as a intermediate vertex. If we take there are 6 vertices, then we have taken 0, 1, 2, 3, 4, 5 as a intermediate vertices. After calculating the intermediate vertices, we find out for every pair of I comma j of a source and destination vertices respectively, there are two possible cases. Here I is the source vertices and j is the destination vertices. That means at the present condition, we have at vertices I and we want to move on vertices j by a edge like this, and if we mark here 4, this is called weight of this edge. K is not an intermediate vertices in a sorted path from I to j. We keep the value of distance I j as it is. We have to find the distance in the given graph by using the formula. K is an intermediate vertex in shortest path from I to j. We update the value of distance ij like distance of ij plus distance of kj. If distance of ij is greater than distance of ij k plus distance of kj, we do not update the value of the given position. When we have to find the value of the given vertices and the value is less than the previous value, then we have to update the value of that position and we calculate the next value by using this distance formula. This is an example which is taken for to show how the value is calculated in case of Warshall'S algorithm. In this graph, there are 5 nodes. The nodes are A, B, C, D and E. That means if we talk about what is the dimension of matrices which is formed in case of the given graph, there are 5 cross 5 matrices we have to form in this given example. And the weight of A to B is 4, the weight of B to C is 1, the weight of C to A is 2, the weight of E to A is 2, the weight of B to E is 6, the weight of C to D is 3, the weight of D to C is 1, and the weight of D to E is 2, the weight of E to D is 4. And this is a directed graph in which we want to apply Warshall'S algorithm to find the shortest path between all pairs of nodes. By using this graph, we analyze this is a directed graph. That means we move from B to C by this way, but we can't move C to B by reverse direction. We have to go by V to C only by using this path. Using this graph, we have to find shortest path. First, we have to draw a matrix. The dimension of the matrix is 5 cross 5, which is decided by number of vertices. There are 5 vertices, so we have to form 5 cross 5 matrices in the given example. This is a matrices which is formed in the given question. We have to write vertices in first column A, B, C, D and E. This is the vertices which is right vertically. Then we have to also write the vertices in horizontal direction A, B, C, D and E. Now we have to find out the distance between each pair of nodes. The distance of each node by self is 0. That means the distance of A with A is 0. So that here we have to mark 0. This position tells the distance between A to A. So we have to mark 0. Here the distance of A to B. In the given graph, the distance of A to B is 4. So that we have to mark here 4. Now the distance of A to C is infinity. Why we have to mark the distance of A to C is infinity? Because in the given graph, there is no direct edge from A to C. So that we have to mark infinity. That means if a directed edge from A to B, then we have to mark the weight of the given edge. Otherwise, we have to mark infinity. So that here we have to mark infinity. Now, the distance of A to D is 5. Because in the given graph, the distance of A to D is 5. So that in the given matrix, we have entered here 5. Now, the distance of A to E is infinity. Same condition. There is no directed edge from A to E. So that we have to mark here infinity. Now, the distance of B to A is also marked infinity. because in the graph there is no direct edge B to A, so that we have to mark in the table infinity. Here this position is B to B. In case of same vertex, we have to mark 0 here. Here also mark 0. This position is also for node D. The distance of D to D is 0. The distance of E to E is 0. The distance of E to C, this position is the distance of B to C. In the given graph, the distance of B to C, there is no direct edge between B to C. So we have to mark the distance between B to C. The distance between B to C here given. The distance between B to C is 1. So that here we have to mark 1. The distance between B to D is infinity because there is no direct edge between B to D. So we have to mark here infinity. The distance between B to E is 6 because there is directed edge from B to E, and the value of the edge is 6. This is called weight of the edge. So that in the matrix we have to mark 6. Same, the distance between C to A is 2. In the given graph, the distance between C to A is 2. So that we have to mark here 2. The distance between C to B is infinity because there is no directed edge between C to B. So that we have to mark infinity. The next is the distance between C to D is 3. There is a directed edge between C to D and the value of the edge is 3. So that we have to mark here 3. The distance between C to E is infinity because there is no directed edge between C to E. So that we have to mark the distance between C to E is infinity. The distance between D to A is also infinity because there is no direct edge between D to A. So that we have to mark distance infinity. The distance between D to B is also infinity because there is no directed edge between D to B. So that we have to mark infinity. The distance between D to C is 1. There is a directed edge between D to C and the value of this edge is 1. So that we have to mark 1 at this place. The distance between D to E is 2. There is a directed edge between D to E and the value of the edge is 2. So that we have to mark 2. And the distance between E to A is 1. There is a directed edge between E to A. So that we have to mark 1 in the given in the construction matrix. Now the distance between D to B is infinity because there is no directed edge between E to B. So that we have to mark infinity in case of B to E. The distance between E to C is also infinity because there is no directed edge between E to C. The distance between E to D is 4. There is a directed edge between E to D and the value of edge is 4. So that we have to mark here 4. This is the distance of E with E. So that we have to mark 0. By using this method, we have to construct this matrix, and this matrix is called D0. Then we have to find D1, then D2, then D3, then D4, then D5. How we have decided to how many matrices is calculated? By using the number of vertices. There are 5 vertices, so that we have to find D1 to D5. That is the calculation of matrices by using the number of vertices which is given in the graph. Now, in the next matrix, first we have to copy the first column and the first row as it is. There is no change in content of first column and first row, which is shown in the given matrices. This is the value which is the previous table. We copy as it is with D0, and now we have to find the value of D1. This is the value of D0. According to given matrix, we copy the same data in this matrix. Then we have to find the value of this cell. And how this value is find? This is the logical or mathematical calculation by using the distance formula which is discussed in the algo. This is the position which we have to find the value. By using previous data, we want to find this value. First, we have to take this is the infinity, then vertical, this is the 4. 4 plus infinity which tells infinity, and the previous value of this cell is 0, and the calculated value of this cell is infinity. If the calculated value is greater than previous value, which is 0, then we don't update the value of cell. That means we write the previous value of that cell, and the previous value of this cell is 0, so that we have to write here 0. Now we have to find what is the value of this cell. Go on this infinity plus infinity, and the previous value of this cell is 1. Infinity is greater than 1, so that we do not update the value of this cell. We write the previous value, and the previous value is 1, so that we can't change the value of this cell. Now what is the value of this cell? The value of this cell is infinity plus 5, infinity, and the previous value of this cell is also infinity, so that we have to do we do not change the value, because both are the same, infinity calculated value and the previous value is also infinity, so that we have to not update this value, and we have to write here infinity. Now we want to find the value of this cell. This cell value calculated by infinity plus infinity, and the previous value of this cell is 6. 6 is less than infinity, so that we can't update the value of this cell. This value is as it is written here. Now we want to find the value of this cell. This cell value calculated by 2 plus 4, 6, and the previous value of this cell is infinity. The previous value of this cell is infinity, and after calculating the value, 2 plus 4 gives 6, and 6 is less than infinity, so that we update this value by 6. This is the method which is used to calculate the value of each cell. Now this value is 0 by using same method. Here 2, here infinity plus 2 infinity, and the previous value is 0, so that we have to write here 0. Now the value of this cell is 2 plus 5, 7, and the previous value is 3. 7 is greater than 3, so that we do not update the value, we write here 3. That means we have to write the minimum value. After calculating the distance of that node, we compare the value of previous value with the calculated value. If the calculated value is greater than the previous value, we do not change. If the calculated value is less than previous value, we have to change the value of the cell. Now the value of this node is 2 plus infinity, and the previous value is infinity, so that if we have to change this value as 12. Now this is the value we have to calculate by the given matrix. In the next step, we copy the value of second column and second row as it is. Then we have to find the value of remaining cell by using 2 column and rows. By using this, we have to find out the value of this node, this cell, and the remaining cell also. Here the previous value is 0, and by using this vertical and horizontal cell, here 4 and here is infinity. 4 plus infinity, the infinity is greater than 0, so that we do not change the value of this cell. We have to write here 0. Now we have to find the value of this node. This node value is 1 plus 4, that is 4 plus 1, that is 5, and the previous value of this node is infinity, so that we do not change the value of the previous value of this cell is infinity, so we do not change the value, we change the value because infinity is greater than 5, so that we have to write here 5. At the same condition, we want to find the value of this node. The value of this node is 4 plus infinity, that is infinity, and the previous value of this node is 5. 5 is less than infinity, so that we do not change the value of this cell. We have to write here 5. Now, the value of this cell is 6 plus 4, that is 10, and the previous value of this cell is infinity. 10 is less than infinity, so that we have to write here 10. By using this method, we have to find the value of all the node here, here, here. We calculate all the value of all the cell one by one. If the calculated value is greater than the previous value, we do not change the value of the cell. If the calculated value is less than the previous value, we have to change the value of that cell. Now, in this next case, we have to take third column and third row as a base. By using this, we also find the value of all cell one by one. Same way. Here, the calculated value is 2. Here 2 plus 5, that is 7, and the previous value at this node is 0, so that we can't change the value of this node. Now, the value of this cell is 6 plus 5, 11, and the previous value of this cell is 4. 4 is less than 10, so that we have to do not change the value of the given matrix. We have to write here 4. We do not change the value which is written by the previous matrix. We write as it is in this cell. We have to find out the remaining cell value. By using this method, we have to calculate the value of all the cell one by one, and we get the matrix like this. In the next step, we have taken fourth column and fourth row as a base matrix. By using this matrix, we now also find the value of all the cell which on question mark, and after calculating the value, we compare with previous value. If the calculated value is less than previous value, update the value of that cell, otherwise go on next cell. By using this method, we have to find the value of this cell. Here 3, 0, 6, 2, 6, 6, 0, 5, 1, 5, 5, 0. Okay. Now, in the next case, we have taken last column and last row as a base matrix and find the value of remaining cells. Here the value is calculated same way which is calculated in the previous case. Let us consider here the value of this cell is 7 plus 5, 11, and the previous value of this cell is 4, so that we have to write here 4. We do not change the value of, because the calculated value is greater than previous value. Same way, we have to find the value of all matrix, and after calculating the value of all matrix, you move on last column and last row. Now, this is your final answer, and this is your final answer. This matrix is called D5. The previous matrix is called D4. The previous matrix is called D3, and before this matrix is called D2, and this one is D1. By using this matrix, this method, we have to calculate all the value. After calculating all the value, we reach on this matrix which tells about the distance between all pair of nodes. For example, the distance of A to A is 0, the distance of A to B is 4, the distance of A to C is 5, the distance of A to D is also 5, the distance of A to E is 7. Next, the distance of B to A is 3, the distance of B to B is 0, because in the first slide we tell you the distance of same node is 0. The distance of B to C is 1, the distance of B to D is 4, the distance of B to E is 6, the distance of C to A is 2, the distance of C to B is 6, C to C 0, C to D 3, C to E 5, the distance of D to A 3, D to B 7, D to C 1, D to D 0, D to E 2. The distance of E to A 1, E to B 5, E to C 5, E to D 4 and E to E 0. This is a matrix that is called answer, that is a final answer, which is show how the distance of the vertices from all pair of sorted path will be calculated. That means in the given graph, this is the, here if we talk about what is the shortest path between C to A, so this is the shortest path between C to A. If we want to talk about what is the distance between E to D, there is a distance between E to D, this one is the path and the distance is 4. By using this way, we have to find the distance between each pair of node. The distance between D to A, there is no direct edge between D to A, but there is a path D to C, then C to E, and the distance is 3, because here is 2 and here is 1. 2 plus 1, that gives 3. By using this method, we have to find the distance between all pairs which is given in the graph. This is all about the Warshall'S algorithm. Thank you.